Hi everybody, welcome back to the great adventure of the Sencore LC-102. Before we get into where we are with this, obviously if you watched the last video where we left off, I found the problem that was causing this to not test and made a repair, and after I made a repair, it didn't work again. So we're going to find out what that is here on this. We're going to do some tests. But before we do that, a couple videos ago, if you go back to part 2 of this LC-102 repair series and look in the comments section, I've pinned a particular comment from a YouTuber by the name of E42. You can see E42 Hobby Electronics, and he did email me and say it was okay for me to share this information. His name is Half. And if I said that incorrectly, please forgive me. It's spelled R-A-L-F, and it's, of course, in the States here, we would pronounce it Ralph. But what a generous, kind person he is. I want to thank him and give him a shout out. He posted a comment on part 2 where he went through and he redid the mainboard schematic. Matter of fact, he made some really clean copies of all 3 of the schematic pages, and he posted them up on his Google Drive. And this one here, he actually highlighted some of the signal paths, and you can actually download this from that comment section. In addition, he partially reverse engineered the firmware to kind of figure out exactly what it was doing, and he wrote this document. It's about 5 pages or so, and it talks about how the firmware works and what it actually is doing in the circuit. Extremely valuable information. I just want to thank him for doing this, because this is great information for me and for any of you who will be working on one of these. These LC-102s are not easy to come by, and when they do come up on on the internet for sale, they're very expensive, and for good reason. They may not be as accurate as some of the really high-end laboratory grade gear out there, but what all you can do with one of these is pretty amazing for analyzing capacitors and inductors. It can do even more than that, and you'd have to read the instructions, but this is good equipment, and to be able to service these now is great. So thank you, Half. I appreciate you and what you did. I wanted to give you credit for the hard work that you did and tell you this is why I do these videos. I mean, when people can come together and share information, help one another, and we can learn these things together, this is why I do it. It makes it all worth it to me to do all this effort. All right, let's move on. So I'm going to take a little bit of my own advice. Whenever I'm at work and one of the engineers is working on a very difficult service call and really getting into the weeds with schematics and things, and they've been working on it for a while, and problems have changed as they have been servicing it, I always say this little saying. I say, show me where you've been and I'll show you where the problem is. One of my friends in the field said that to me one time, and that's kind of, that saying has stuck with me. So we know that it worked before I serviced it, and here's the phone. And then of course, just it worked by putting this chip clip on there and putting a jumper between pins 4 and 10 of IC27. So of course, the last part of the video there, you saw that I removed the IC. I put a jumper across the bottom of the board, and then installed this socket and put the chip back in, and lo and behold, it didn't work again. And it was not the jumper this time, it was something else. Now, I tried 2 things before that video ended. I didn't do it on video, but I tried 2 things since then. Thing number 1 was I put a new LM319 in there because maybe I overheated the chip and it failed. That did not fix it. The other thing I did was I measured it, and I measured it and verified the pins 4 and 10. And then the other thing I did was I pulled the board back out and I reflowed all of the 14 pins of the socket, because again, this is a double-sided board, and you see how tiny teeny the pads are, and since they don't have plated through holes, they just have a pad on the top and a pad on the bottom, and really the plated through hole is the actual lead of the component. It's possible that I didn't get solder all the way onto the top of the board. So I reflowed all those, made sure that was good, and still I did not have any success. And that's kind of where we ended the video. So what I'm going to do, picking up from there, is I'm going to go back to this chip, because I have not touched anything else on this entire board. There's not very many plugs, and it's pretty obvious if you have them connected securely or not. So I'm going to go through with my ohm meter, and I'm just going to ring out all of the connections to this chip to all of the external components to make sure we don't have another broken trace. So that's what we're going to do right now. Okay, just for consistency for all of us, we're going to check pin 4 to pin 10 once again to make sure that we have continuity on that. So there's pin 4, and there's pin 8, 9, 10. And you can see it's connected, so that's good. I then want to make sure that I have a connection from pins 4 and 10 down to, what is that, pin 8 of IC23. It's right here. So we're going to go from pin 8 of IC23 to pin 4 of IC27, and yes, we have continuity. So once again, that's good. Pins 3, I can't totally read that, but pin 3 and I believe that's pin 8 are tied together, and they go to ground or common. So 3 and 8 should both be together. So if I go from pin 3 to pin 8, let's see, am I on it? Hold on, oh, it would help if I was actually on pin 3. There we go. Pin 3 to pin 8, all right, so we have continuity there. And then if I go from 3 and 8 to the ground pin, which is down here, we have continuity. So that's a good circuit. That's good. Now over here, we have pin 7 to pin 12. There's a diode in there. So if I go on to diode check, and I go from pin 7 to pin 12, in one direction, I read a diode drop. If I go from 7 to 12 in the other direction, we're reading those resistors. And if we see there, it loops up through a 10K and into a 470 ohm resistor. So if I read from pin 7 to 12 with our meter in ohms mode, I should read roughly 15K. So if I go from, what did I say again, pin 7 to 10, 7 to 10, wait a minute, 7 to 12, I'm sorry, pin 7 to pin 12, pretty close, 10.3K, I said 10.5, but of course we have that diode in there and who knows what else, so, and the chip. So those resistors, so we absolutely have continuity to all of these things. Pin 5 goes to R81. So let's check pin 5 with respect to R81 and R76. Or I can read pin 5 to ground and it should read 10K. So let's do that first. So pin 5 to ground. So pin 5 to ground It's 8K, so there's something, you know, there's other things in there. And if I go from pin 5 to, looks like R181 is a 49.9K. So I think that's right here. That's one side. And there it is. So definitely that pin's connected to everything. The only one left here is pin, what is that? 9. So pin 9, and there's that TP3 there. So I think we're gonna be okay here. So pin 9 to, here's TP3. And there we go. So that's good. Is that? Yes. Then pin 11. To our 12 volts, which is going to be P5 pin 5. Or P6 pin 5. 1, 2, 3, 4, 5. This would be this white wire here. And that is pin 11. So right here. And we have that. And then our negative 5 is, what is that? Pin 6, I think is what that is. It's either 6 or 8. Pin 6, I believe. And that goes to P6 pin 2. So if I go pin 2 and pin, is it 6? Yes, there it is. And then I should also have a connection from R74 to pin, what is that, 9. So, is it 74 or 72? Yeah, 74 to pin 9. Or no, 72 to TP3. Because I got to be able to get all the way back to this pot. So if I go from TP3 to 72, four megs. Okay, I'm on the wrong side. 4 megs. That's not right. Wait a second. Let's make sure I'm on this. TP3. We verified it's connected to here. And it should go to R72. This is R72. There it says R72 right there. You can see it. And this is that. This one has a solder blob on it, and it's scratched up. This was removed and put back in. Again, this person that was working on this before, he knew what he was doing. He was right on this. There's no connection there. Huh. Well, let's heat this up with the soldering iron and see if maybe it's just not in there right. We don't have a good connection. Okay. Touch this right here. You know, that's not even, that doesn't even have a lead. That's just a solder blob going down in there. That moved around when I touched it and heated it up. Okay, let's see if that fixed it. Nope. Okay, let's do like we did the last time. Let's put a jumper. So if I go from here to TP3, let's see if it works. And that is a 16.9K resistor. Wow, that's an odd value. All right, let's prop this up. I'll tell you, this circuit board is hard to work on. It's just very, very delicate. Okay, let's turn power on. Okay, leads open. And it works. It wouldn't do that before. It locked up. Let's disconnect this, and just for giggles and grins, I took it off. And it locks up. You see that? And if I connect it, there it goes. I have another bad connection, another bad trace in the board. Okay, let's short the leads. So I'm going to short them. Hit short. Huh. Okay. Let's try our different values of caps again. Where's that one that I had? Here it is. Okay, so this is our 1500 picofarad capacitor that we made on the last video. And it's right back to reading 434 picofarads. So it's definitely not accurate, but it is reading something. If I go to the 100 microfarad, that's going to take us to another range. And remember, this was working before, but it was just wrong. And it's about a little over half, so it's 63 microfarads instead of 100. And then going to the high range, for the high capacitance range, it switches in that 400 and whatever it is, it says right here, the 416 milliamp current source, because the other ones are all microamps. I think they're very low, but this one's a high one. And this one seemed to be a little more accurate. And you can see a 2200 microfarad is reading 2100. It's jumping around right now. So I think we have something. It's working, but I think once again, either we have a bad logic gate, a bad transistor, a loose connection on the trace, something like that. It's causing the scaling to be incorrect. And I don't think it's the calibration, because all the ranges seem to be off by a similar amount. So I think we're still troubleshooting some bad connections, unless there's something funky going on in here. But we'll have to measure all that. But let's make this repair to this board. I think the first thing I need to do is see if I can dig up a 1.69K or 16.9K resistor. Okay, so I removed the resistor from the board, and you can see it's in two pieces. So what must have happened is, when whoever was testing this, they wanted to check something, in order to lift this, instead of heating it up and pulling it out, they cut it. And then they just pushed it back down and put a blob of solder on it to attach it back together. Now, I don't think that in itself was the problem, but definitely one of the traces over here somewhere, and they're very tiny. Some of these traces are thinner than a hair. You know, just how densely packed this board is. But right here are the two pads, and you can see how tiny some of these traces are going in through here. So I don't know. I'm going to have to inspect this very carefully under a magnifying glass. Okay, looking at all the bins over here, and you can see how many full of resistors, I do not have a 16.9K. I am now in my spares and odd value resistors tub, and I am going to sift through all of these and see if somewhere in here there may be a 16.9K, but I highly doubt it, and I will either have to make one or I will have to order one. And okay, this is what I found, and this is what I'll just have to do. The original clipped off one resistor is reading, if I hook it up here, and we're going to use our Kelvin leads, and we're going to use a pretty high accuracy meter. You can see around everything here, 16.96K. So it's 16,960.5 ohms. And let me move my mic. Okay. And if we go down to this, I hand-picked a 3.5 or 35K and a 33K. And I just kind of went through different combinations. And I came out with this one, which is 17.014. So it's 17,014 ohms. Very close. Now, this resistor here, the original, has a brown stripe for the tolerance, and that means it is a 1% resistor. If I can get this to focus. Come on, you stupid camera. Okay, so it's a 1%, and 1% of 16.9K would be 169 ohms, so you can be plus or minus 169 ohms. So if I'm at 17K, I am within that 1% tolerance. So this should work, at least for us to continue on with our troubleshooting until I can get the correct resistor to put in there. Okay, the resistor is in, and we made the little jumper from here to here, just like the one that went from pin 4 to 10. And just to adhere this so it doesn't move around and get nicked or anything, I put some of this Bondic UV curing glue. This is great stuff for where you just need to instantly adhere something. So just put a drop in there, and then you turn on the UV light, and that cures the glue instantly, and it hardens, and that'll never move. So that's a nice permanent fix for that. If I do decide to swap this resistor out for an actual 16.9K precision resistor, it'll be easy enough to just remove the solder from there and pop it back in, and we'll be good to go. Okay, everything's back together now, and our janky makeshift resistor is installed. And let's turn it on. Okay, let's do our open leads test, and it works. Let's do our shorted leads test, and it seems to work. Now, the only thing I'm not sure about is, if you notice, when we do the open leads test, that little dash scrolls across the screen. But when we do the shorts test, it just comes on and then turns off. And having not owned one of these in the past, I really don't know if that's correct or not. All I do know is that after a brief moment, like it says in the manual, it does clear and go back to 0. So if I go back to putting our 1500 PF capacitor in there, and I do capacitor value, and it's the same thing. It says 435 picofarads. So now we're back to the point where we need to see, do we have a problem with our current sources? Because you have these transistors that could be bad, they could be leaky or something. We could have a problem with these little PAD20 diodes, these little picoamp diodes, I think they call them, or something like that. Or, something associated in there. Or could it be something down here in the reading circuit, or in the measurement circuit, where it measures what's coming back? So I think the first thing I'm going to do is, all the problems so far have seemed to be in this area. So it only stands to reason that we should start by troubleshooting this part here. And I'm not sure how easy that's going to be in circuit, because I don't really know what these are all supposed to be. And it really doesn't talk about it in the theory of operation. A lot of these signals are pulsed on and off, so it would be very hard to definitively know, without knowing exactly how this circuit's supposed to work, if it's working right or not. But we'll try. Worst case scenario, these transistors are very basic transistors that I probably have in stock. I know I have the 3904s, 2N3904s, and I'm pretty sure I have the 5771s or something very similar to them in stock. I believe IC22 I have replaced already, and IC23. I think they're up on sockets, but I can verify that as well. Maybe one of them is not. But it has something to do with that. It seems like when we're in the high current test range, 2,000 microfarads up to 2 farads, it seems that it's more accurate there, and I probably will be able to adjust this. So that kind of rules out this measurement circuit as being bad, because if you put the correct current source into it that it's expecting, the readback circuit seems to work. So I think it has something to do with these low current sources, or something related to them, where our problem is. So with that all in mind, let's start checking some of these things. Okay, the plot thickens. So I've studied this a little bit, and I was going through this description once again, and I found this very interesting part right here. It says the upper and lower voltage trip points are determined by the voltage on pins 5 and 9 of IC27 and LM319 high-speed comparator. The lower trip point, pin 5 of IC27, is normally held at 1 volt by resistor divider network 161 and 76. Now, if we look on the schematic through all my messy papers here and all the junk on the bench, here is R161 and R76. Here is pin 5. And right at that junction there, you can see you have 6.2 volts going in to 161. And with none of these being turned on, if this is just sitting here like this should be 1 volt. And let's do the voltage divider software or calculation on this and make sure. Okay, doing the math, we have 6.2 volts at the input up here. If we have 6.2 volts, which we have to measure that, and this top resistor is 49.9K, this bottom resistor is 10K, so that would be R2. The formula for that would be V times R2 divided by R1 plus R2. So if you take the 6.2 volts times the 10K, that's 62,000. Divide that by 49.9 plus 10K, be 59.9. You're going to get 1.035 volts. So that's correct. That's what we should have. So let's go over here and look at our voltage, and you'll see what the problem is. You can see I've already removed the LM319 because, as you're going to see, this voltage is not right. It is incorrect. So I'm going to back you off a little bit. And if you look on pin 5, you can see, if I can get the probe on there, it's 0.19 volts. It's not even 200 millivolts. It should be 1.035 volts. So the first thing we want to check is that 49.9K resistor, which is up here. And we don't quite have 6.2 volts. We have 6 volts. So that's a little bit low, but I don't think that's the end of the world. If I look at the other side of it, though, 200 millivolts. So what's up here? We either have this resistor has changed, or here's the 10K resistor, and I can see where it's been lifted and put back down as well. And there's the junction of the 49.9K and the 10K. Here's ground, and if I check here, I have ground there. Okay, we'll turn the power off. I have ground there. And so now let's see, let's go at that junction point. Actually, I can't get in there with these little hooks, they're too big. All of the connections on this board are so tiny and miserable to work on. This is a miserable little board to work on. It is definitely will challenge your patience. So if we go across the 10K resistor, let's see what we have. It's only 9K, so that's reading incorrectly. And if I read across the 49.9K, that's really messed up. It's reading 10K, and it's charging like there's a capacitor there, which there is a capacitor. Well, no, there isn't. There's something wrong here. We're gonna have to pull these resistors because there's something in the circuit that shouldn't be. That's completely wrong. If we look down here once again, the only connections in here are these other resistors. If TR40 or 41 are shorted to ground, then that would bring one of these resistors across that. So there's a possibility that either TR40 or TR41 is leaky. I don't know. Or we could be just... No, that would be it. So, because these should not be connected to anything in here. So we may have a bad TR40 or 41, or one of these resistors may have changed values. I don't know, but that's completely not right. So let's check out, let's pull some components and take a look. Okay, I've pulled these two resistors. Here's the 10K, and it's right on 10K. Here's the 49.9K. And it is slippery, but it is 49.81K. Okay, just so I don't have them mixed up, I marked TR41 with a red dot, and I marked the associated hole with a red dot. You can see there. And if we put these in here, so there's the reading for that one. Just take a look. You can pause the video. I may do that myself. Put the other one in there. Make sure it's in there correctly. And it's slightly different, but you know, I would say that's okay. Okay, I have TR40 and TR41 pulled out. You can see right there the empty slots. And when I go to my IC27 pin 5, which is supposed to be 1 volt, and let me get the ground lead. There it is, 0.996. So we have our 1 volt now. So even though these FETs test out good, for whatever reason, they are causing that, they're dragging that voltage down. And the only thing I can figure is, well, I can't figure. So they're connected to here, but you have a 2.7K and a 7 point something K resistor in here to ground. So even if you added that into there, well, I guess that would reduce it below 1 volt. So one of these might be either shorted or turning on full time, or being told to turn on by the microprocessor. If you look, here's the 2 lines that go directly to the microprocessor. And I checked up in this area here, and none of these components seem to be bad. So I don't really know what to think. Okay, that's pretty strange. So going back to the schematic, these are both turned on right now at the same time. So it's bringing both of these to ground at the same time. If I go over to these 2 gates, or these 2 outputs here on the microprocessor, one of these is reading like 5 volts, like you would think if it's like an active high. But this one right here, which is going to, what's this over here, going to TR41, it's not 5 volts. It's kind of halfway between. It's like 3 volts. And if I go from ground to it's TR40 or TR41, there's 3.3 volts there. Okay, moving ahead, I've taken this section of the schematic and just cut it out, and I highlighted some of the lines that we're interested in here with all these problems. And I'm still focusing on TR40 and 41 at the moment. Now, I was not sure where these are being derived, and well, we'll get into that later, but this is supposed to be 1 volt, and if this isn't 1 volt, I know that it's not going to be able to calibrate the probes. That seems to be the problem. And when I go in here and I go on pins 30 and 31, so let's go over to the scope. And I'm going to go on pin 30 first of all. And you can see I have this wonky looking signal there. And you can see it kind of chatters. If I move it in, you can see what it's doing. I hope you can see that. And if I go to pin 31, it's just a solid high. And if I hit the capacitor test button, it's really not doing anything. It just kind of sits there and looks funny. If I go to pin 30 again, and I hit, you can see the noise goes away, but that one solid pulse stays there. And then when I let off of the capacitor value test, it comes back. I don't think that's right. And here's why I don't think it's right. Looking at this, each of these resistors can go to ground through its respective MOSFET. And that is controlled directly by the microprocessor here, if you look. And of course, we're going to get a reduced voltage here because you have a voltage divider, these two 10Ks with a 5 volt pull-up right here. So it's not going to be 5 volts because this is going to turn this transistor on right here. So you're going to have a voltage divider. So you have the 10K plus the, what is it, 0.6 or 0.7 volt drop here. And then it's divided with this 10K right here. So you're going to get about 3 volts, which is what we're getting. And we're getting that weird looking pulse. And then on pin 31, it's just solid on the whole time. And there's really no pull up for it. So somehow it's getting a high signal all the time right here. And I don't think that's right. These have to turn off, and because when they're turned on, they're going to put, each one of those is going to put one of these two resistors in parallel with this 10K. Because look, this is ground here, and so when you pull this line here through here to ground, you're going to put this 2.7K right in parallel with this 10K, and also conversely with this 7.8K when this turns on. They're both turned on at the same time. So you have a 7.8K, a 2.7K, and a 10K all in parallel right now. And that's being divided with this 49.9K resistor through the 6.2 volt supply. So that's totally wrong. And this never, I mean, what you saw was right there. I mean, that's it. So what I need to know is what this is supposed to look like. So I'm going to post a short video, and I'm going to put it up on the channel, and see if any of you have one of these that you could measure pins 30 and 31 in here, and see if we get anything. So I'll be back after I do that, and we'll see what happens. Okay, I did hear back from all of you, and it wasn't even 24 hours. I was just loaded with comments. I just can't believe it. That video that I posted on this is a little 12 or 13 minute video. It shot up to #1 on my channel in, within an hour. I just can't believe the outpouring of help I got. I mean, I'm flattered. Thank you all so much. So where are we right now? Well, I got a couple good suggestions, and I did get somebody who sent me some waveforms of what this is supposed to look like when it's working properly. It's definitely not right. So one suggestion that you all gave me here, and by the way, there is another part of the video here that I'm going to post up afterwards where I find, and I mentioned this in that short video, about these current sources. This is still a problem here too, but I'm not even going to worry about that yet. We got to fix this. So one of you suggested putting this chip up on a second socket and folding these pins in on the socket to take these out of the circuit and see if these pins have a problem, if this chip has a problem on it, the MCU, or if there's something weird going on here. Now, I replaced these two with two brand new 2N7000s, and it made no change at all, made no difference. I verified the 6.2 volt, the Zener for that, which is being derived. I couldn't find it. Mr. Magoo here can't see anything. Right there's your 6.2 volts. Okay, so it's right under the ADD converter to IC14. And you can see right there is a 6.2 volt Zener, and it's good. Okay, I changed it out. The original one was only reading just on about 5.9 to 6 volts. I put a new one in there. It's about 6.15 now, so it's right where it should be. Again, no change. It didn't do anything. So what we're going to do now is I have this up on a socket, as you saw before. I'm going to fold those pins under like what was suggested, and we're going to see what it looks like. Okay, as you can see, I have these two pins just kind of folded under there, and I'm going to plug this back in now. Okay, the chip is in, and okay, we turned it on, and I'm going to probe now pins 30 and 31 once again. I don't know why previously I kept calling this in that other video 10 and 11, but all I can think of is I was counting from here. I was counting the 10th and 11th pin up, and I was calling it 10 and 11. I know better than that, but sorry for confusing all of you. But anyway, here's pin 30 and pin 31. Let's get on the scope, and let's see with the pins disconnected now, just floating. Here's pin 30. It looks the same, pretty much. Let's hit capacitor value. And it's basically doing the same thing. Okay, so I'm going to go to pin 31, capacitor value. Same thing, it's not changing. Sometimes you see how it real quick it glitches one time and then it doesn't. And let's see if it'll do the open and short leads zeroing. So here's open. And it's hung up. It's definitely hung up. Alright, so let's see. Let's go back down to our schematic. And let's check. Let's see our better one. Let's check pin 5 on the IC27. And let's see it with those two pins lifted. These should not be on, and I should have my 1 volt there, right? That's what I should have. And you can see on pin 5, I still have 200 millivolts. So, what that tells me is that even with these pins folded over, it's not changing our situation. Okay, if that's the case, let's go and look at the gates of TR40 and TR41. Okay, so the gate of TR40, that's right here. If I touch it, it's low. And if I go to the gate of TR41, look at that, 2.79 volts or 2.8 volts, which TR41 is this one with the orange line with this voltage divider, and you can see you have this 5 volt pull up. That's exactly right. So this is correct here, and this is correct now. So it should, we'll see what happens, it should let us calibrate the leads now. Let's see if it does. Yep. And then let's do the short. Let's short the two leads together. And it works. And if I try to read this right now, it's still reading the same thing. It's reading wrong, but it is reading. Okay. Okay, I'm back on pin 40 or pin 30 of the microcontroller, and I've not touched anything other than the last scene you saw where I was measuring those two transistors, which are not connected to the chip. And look now. See how it's going low and then high? Now just remember 2 minutes ago, 2 clips ago of video, it was not doing that. I've not touched anything. Let's go to pin 31. Remember, 30 and 31 are not connected to anything right now. I have them folded over. And look at that. I honestly have done nothing. I think there's something wrong with this CPU. I do. I think there's a problem with that. And I think that this MOSFET, I think the only reason it was reading funny is because they're MOSFETs. If there's nothing on the gate of the MOSFET, it's very easy for it to start to conduct on its own. So I don't think that's a problem. And when I put my meter probe on there, that discharged it enough that it started working there. So where am I right now? Well, I am really beginning to think that this chip is bad, that this TMP80C39 is bad. Now, let me share something else with you from the comments section. Okay, I'm going to read you 2 comments from my little short please help me video that I gave. Let's do the first one. This is from My Radio Videos. Thank you, sir. You're awesome. So he says, so about 10 years ago, I purchased a pallet of surplus test equipment. This was from a repair facility that shut down after the owner died. In the lot were 5 Sencore LC-102s. In the end, I spent weeks trying to fix them, and in the end, I had to use 2 of them for parts to get the other 3 to work. I swore I would never try and repair these again. One came up on eBay about 8 years ago for $150 not working. As you know, these can sell for well over $1,000, so I figured let's get it and try and fix it. Lucky for me, after a few parts swap, the microprocessor, the unit came back to life. So after 6 units, 2 had bad processors, and that might tell you something. So he says, during COVID, I decided after retiring to clean house, so I sold off the parts units. And he says, I've been following your videos, and you're on the right track, but the issue with the LC-102 is they definitely have reliability issues, and in my case, it was not a single failure of a single part, but rather multiple issues. That is what made it so challenging. All right. And he said, by the way, I found a logic probe, very handy to use, as well as a pulse injector probe. And as a matter of fact, where are mine? I had them out just not too long ago. I was using them. I think I put them away, but yep, I was messing with those a little bit. So that's the one thing. And so there you go. Out of 6 units, 2 of them had bad processors. And what I say early in an earlier video, these don't fail that often. Another person said, hi Tony, in my experience, most of the I/O pins on these MCUs are protected with internal diodes connected to power and ground. You might want to try removing the MCU and measuring between the suspected pins and the power or ground pin using the diode scale. At the very least, you can check to see if the pins are shorted to power or ground compared to the other I/O pins. And that could very well be, but being that just sitting here, sometimes it'll toggle and sometimes it won't. And when the pins are connected, it never toggles. I think this is a bad chip. Now, how are we going to replace this? Well, the 80C39s are very hard to find, and they're identical to an 80C49. The 49 just has basically one of these ROM chips, or the equivalent of the ROM, like a 2K ROM, built into the chip. And you can either use that or not use that. If you choose not to use it, there's a pin on here that I think you set it to high, and that'll tell it to ignore the internal ROM and look at the pins, the external pins, for an external ROM. So I think, long story short, if I put a 80C49 in there, it should drop right in and work. There are also several other versions of these chips that will also work. There's a newer version, and I think it's called an 80C58 or something like that. I'll have to look it up, or a 51. But it's basically, again, this chip with additional instruction sets. It's a new and improved version that's backwards compatible. So I'm going to dig through all my old stash, because a lot of the X-ray equipment out there used similar chips, these 80 series processors. They were used in everything. I'm going to see if I can find one, and if not, I'm going to try to order one, because the 8049s I think I can get pretty easily. The 39s weren't very common. So I'm going to try that. I'm going to swap that out. Now, in addition to this, I did extra digging, and I think we have yet another problem with this thing, and that is with these current sources. Once you get the scaling set right with these 2 transistors here, and we sort that out, you still have the problem of these current sources that have to be, they switch in based on the value of capacitor. So this one's a 3.3 microamp current source, this one's 330 microamp, a 60 milliamp, and a 416 milliamp. Now these transistors here could be a problem, and these picoamp diodes, if I read correctly online, went to some of the forums, These seem to be a very, very common failure item. So what we're going to do is I'm going to show you here, we're going to go through and test these couple of things, because you really can't test them in circuit. You have to just pull them out and put them on a component checker. And we're going to see what we have here. So that clip is coming up next, and actually I'm doing this after the fact. I have already done that. I'll put that clip in right now for kind of consistency, and we'll do that. Once I show you that part, then I'm kind of in another holding pattern until I can get one of these microprocessors. But I think we're getting very close to figuring out how what's wrong with this and how to get it fixed. So I've replaced TR11 and TR12 already. Have the board out, and I pulled CR, what is it, 29 and 30? Yeah, CR29 and CR30, these picoamp diodes. What is a picoamp diode, you may ask? What these is the function of them is a diode, okay? But the actual component in here is a JFET that has the gate tied to the source, I think, or something like that. And so it's a two-element device, and it acts like a diode, but the difference is forward voltage drop is similar to a silicon diode, but in reverse, the reverse leakage current is super low. That's why they're called picoamp diodes or pad diodes. And the whole purpose of that is they can switch off very quickly when you reverse the voltage on them, and there will be no leakage. So that's really important in the circuit, because again, this has to turn on and off very, very quickly, and any kind of reverse leakage will affect that signal that you're testing. Now, that being said, if we test the first diode here, it's a diode. When I tested this second one, it's not a diode. I think that's part of our problem. Now, again, this is for the 60 milliamp current source, but I don't know if it still comes into play when these other two are coming in. That's definitely a problem. So we're going to replace those. Now, I do not have pad 20 diodes, but I have these JPad 20s right here. And the main difference is these are just in a plastic case instead of a metal case, and they are supposedly a drop-in replacement, hopefully, because that's all I have. If not, I'll have to try to find these and replace them. But I think those are going to work all right. Let's try it. If they do work, that's great, because they're readily available. You can still order picoamp diodes from that manufacturer through Mouser and DigiKey and so forth. All right, so let's install those and let's see if this makes any difference. All right, so I replaced the two pad 20s, and of course I put it back together and it quit working again. Well, it didn't really quit working. If I try to test the capacitors, it would still test the capacitors and it would be incorrect, and you still couldn't adjust it. Now, what I found out was something's going on in here with the scaling, because these are both being turned on and held on all the time. They never change. Now, I tried replacing these two with brand new 2N7000s, and it still did the same thing. I lifted one side of each of these resistors, this R162 and R163, and when I lift them, I can then calibrate the probes. And everything starts to work, but again, it's out of scale. It's not accurate. This leads me to one conclusion. There is only one connection from here directly to the microprocessor and from here directly to the microprocessor. And these never seem to really toggle like they're supposed. They don't seem to drive like they're supposed to. There's really nothing else in the circuit. All you're doing here is by turning on this or this, TR40 or TR41, is you're bringing another resistor to ground in parallel with this R76 10K resistor. You see that? So you're changing the scaling of this. So this 6.2 volts is a reference. And with these out of circuit, it should be 1 volt. And we proved with these pulled out, it was 1 volt. But as soon as you put these back in and turn the machine on, it stays at like 0.1 volts. And it doesn't, even though these things do seem to pulse a little bit, they don't seem to change the scaling. And according to the theory of operation, this is supposed to be sitting at 1 volt. It is not, because both of these are turned on. So if you take this 2.7K and this 7.8K and you tie them to ground through TR40 and TR41, you are putting this, and this resistor all in parallel, which is going to give you about 100 and some millivolts. That's it. So the only conclusion is the microprocessor is not driving these two ports. Now, helpfully, let's go back to Half's page that he drew up of how the MCU selects the components. And again, just like I was thinking, P13 and P14 control their outputs. They control the gate of TR41 and TR40. So, and it's just basically what I found in here. So this has been a wealth of information. I started reading through it, and there's a lot of good information in here that he shows us on how this works. I have a replacement microprocessor. I really did not want to replace it unless I absolutely had to. But I'm at the point now that I just can't see any other thing that would cause this.